Right kids, this is what we're doing today. We're doing linear graphs. Your LOs are above. And your starter is what's in my bag. So you practice your substitution skills, and it's just a bit of a good thinking exercise for you guys. So we've got, clue 1 is f plus x. So you've got f, which equals 36, and x, which equals 4. So we're going to substitute those in, and you're going to get 36 add 4, which equals 40. And if you look at 40, 40 is worth e, so you write the letter e down. Now, next clue is 4x, so 4 times x. That's going to be 4 times 4. Which equals 16. Now, let's have a look. What letter is 16? It's P. And the third clue is k minus w. So we're going to go to k. Let's have a look. Where are you, k? 25. Minus w. W, you can see here, is worth 5. That equals 20. What letter represents 20? That is N. So we've got the letters E, P, N, and yes, you spotted it, the word or the item in my lovely pink mulberry bag is pen. Now here's 4 to try yourself. I'll just start you off with the first one. So you've got W times W. So that's going to be 5 times 5 equals 25. And 25 is K. Now you've got E plus T. E is 40 and T is 8. So you have 40 plus 8 equals 48. What letter is 48? It's B. M minus Y. M is 21 here, and Y is 3. 21 minus 3 equals 18. And so 18, you can see on this grid, is the letter O. 18 equals O, so this one must equal O. So the letters we have is K, B, O, O, and you've got it. The word is book. It is a book that's in my mulberry bag. Right, try the other 3 yourself. They are all items that are literally always in my bag. And see if you can solve the anagram once you work out the letters. Great practice for your substitution skills and just to get your brains in gear. Pause the video and give it a go. Answers are coming now. Number 1, book. 2, you've got pencil. Excellent. 4, ruler. And 3, that's the star question, because people always struggle to work out that word is the planner, because we don't use it as much as we should. Right, let's move on. X-axis, Y-axis, hopefully we remember those terms. Now, just something you need to note for the future. You do need to be aware of these terms. Coordinates that are in this section of the graph, the positive X and positive Y, that's called quadrant 1. This side is quadrant 2. And quadrant 3 and quadrant 4 and so forth. So it's just quite easy to remember. Start with 1, you go anti-clockwise, 2, 3, 4, and that's just the meaning of quadrants, and you're supposed to know that. But I've never seen it being asked in a question for a long time, but it might appear, you never know. Something to remember or make a note of. So what are the coordinates? Just a recap, because you have to be able to plot coordinates to draw linear graphs, and plotting coordinates is worth marks, GCSE marks in the exam. So you can see you always go across the hall before you go up the stairs, or imagine before you get to maths, you always walk across the corridor and then go up the stairs, or walk through the school gates, walk up the stairs, or down the stairs. So it's across the corridor, up the hall, and that's minus 4, 4 here, you can see, and that's going to be minus 5, 0. Perfect. You should get that correct. Let you do these to yourselves, and I'm sure you're going to ace these questions. So let's go. So red is 3 minus 5, and green is 6 minus 4. Well done. Coordinates again. Try yourself. Now you can see it goes from minus 7 to 2. And that across the hall and down the stairs this time. 3 minus 4. That represents the x coordinate, that represents the y coordinate, and we'll need that later for when we're using table values. Right, some quick questions for you to try yourself. That's just going to take you like a minute. Pause the video, give it a go. Answers are here. Well done if you've aced that. Just a quick recap, guys, from previous lessons, and check your prior knowledge. That line is y equals 1. Yep, because every coordinate here, the y value is 1. So it's quite straightforward. All the other lines, just draw it in your mind, or run your finger across your phone or your computer screen instead of drawing this all out, just to put it into your muscle memory. Pretty straightforward. Quick recap. Draw the line x equals 1. Well, you knew what y equals 1 is, so hopefully you'll remember x equals 1 is this line, because every coordinate is 1. So draw those lines with your finger. You don't need to do it in your books. And hopefully that cements that into your memory. Right, draw a graph of y equals 2x plus 5. Right, we haven't got the numbers on this graph, but we're going to use a scale of every square is worth 1. And let's get going. So, sometimes in an exam question, you may not get a table of values. So just do one, because that's going to be worth some marks. A lot of the time, most of the time, they do give you a table. So here's your table. So this is your y value, this is the graph, and this is why the substitution comes into fruition. Right, so I always start with the 0. So we've got y. I'm going to start with here. So when x equals 0, y is going to equal, substitute the 0 for the x, that's 2 times 0 plus 5. 2 times 0 is 0, so y equals 5 here. Now let's do for x equals 1. So that's going to be 2 times 1 plus 5. 2 times 1 is 2, that comes 2 plus 5. So that's 7. Let's just do one more. When x equals 2, let's write that over here. So when x equals 2, y then is going to equal 2 times 2 plus 5. That's going to be 4 plus 5 equals 9. I'm going to fill that in. Now, if you remember sequences like 2n plus, let's do the first 5 terms of this sequence, 2n plus 5. So when n equals 1, the first term is going to be 7. 2, when n is 2, it will be 9. 2 times 2 plus 5 is 9. And 11. So can you see the pattern? It's going up plus 2. Plus 2. This is essentially exactly the same. You can see that pattern, plus 2, and you can do 11. And that will be the correct answer. So once you've got those correct, and that obviously follows a pattern, this works for all linear graphs, and that's linear graphs only because it's a straight line. So if it's going plus 2 this way, then you should know that's going to be minus 2. So 5 minus 2 is 3. minus 2 is 1, 1 minus 2 is minus 1. And then you filled in that table of values very quickly, and that's worth 2 marks on its own, in general. And there you go, the numbers are popping up inside. Plot those coordinates on the grid. So remember, let's choose this one, that's 1, 7. Up there, that's 2, 9. So remember, that's the x coordinate, that's the y coordinate, x and y, and you just plot those. You plot most of those correctly, and that's worth 1 mark. Draw a straight line through the point that covers just the area of the graph, and that will get you your next mark. Label the line y equals 2x plus 5, that's just good practice. And then that's it. You've drawn a linear graph at grade 4. So, on the same graph, plot the following functions. Those 3. So, let's just start you off. And I'm going to make up an example here, because I don't want to use example here. Let's say e.g. Let's say this is y equals 3x minus 2. So y equals 3x minus 2. Let's start with the 0. So when x equals 0, we substitute that into the x. That's 3 times 0 minus 2. Remember your rules of bid mass, multiplication first. 3 times 0 is 0, and so 0 minus 2 is minus 2. Let's try it with the 1 now. So y equals 3 times 1 minus 2, bid mass. So that equals 3 minus 2, so that equals 1. And we put the 1 in right there. And it's just good practice, we'll just do the 2 now. Let x equals 2, because we're plotting this, y equals 3x minus 2. Sometimes it helps just to write that there. So x is 2, so we do 3 times 2 minus 2. That's 6 minus 2, which equals 4. Right. Because we're always timesing x by 3, that's why you can see there's a pattern of plus 3. Can you see it's going up by plus 3? So once you've done 2 or 3 of these and can spot the pattern for linear graphs, you don't need to substitute all the time. So you know this is going to be minus 3, going the other way, minus 3, that's going to be minus 8. So give these a go yourselves in your books or on a bit of paper. I'm going to start with 0, so when x equals 0 here, that's going to be y equals 2 times 0 plus 3. That bit equals 0 plus 3. That equals 3. Now if you get very good, do this mentally. 3. So x is 1 here. 2 times 1 is 2, add 3 is 5. Now 2 times 2 is 4, add 3 is 7. Now you can see the pattern, it's going up by 2. So that must mean that's going down by 2. And then you fill in your table of values very quickly this way. Right, give the other 2 a go. Pause the video and I'm just going to put the answers in. Right, I can substitute that in my mind. That's going to be 1. 1 times 2 plus 1 is 3. And look, then you've got the pattern, it's plus in 2 each time. That's why it's always better to start with negative numbers, because you're more likely to make a silly mistake with negative numbers. Right, now 2 times 0 is 0, minus 4, 0 minus 4 is minus 4. Now I know this pattern is going to be going up in 2s because of the 2x. But do this any way that you're comfortable with, guys, because that's what's important. Now it's very important here, just want to show you that if you're substituting, that equals y equals 2 times minus 3 minus 4. You work that out first, right? So you're going to get minus 6 minus 4. I know some of you have been taught 2 minuses make a positive, so you might make that answer number 10, but it's not 10, it is minus 10. It's only when you have something like this, when they're next to each other, that it changes to a plus. Okay, and that, and only in that instance it's 10. That's a common misconception. Right, let's move on. And obviously this is a page you can print out or draw it yourself, and that is the correct answer if you plotted it. Right, this is the hardest part really, because plotting coordinates is easy and using a ruler is easy. Once you've got this perfect, you'll get this perfect. Right, let's move on. Now, there's some different sheets for you to practice. It's red, orange and green, green being the most difficult. The questions are here. And there's different questions, so you know, just pause the video at the right point and use it as you wish. This just gets you a bit of practice. Yeah, blue is an extension. Right, so pause the video, give it a go. If you get the table of values right, just try a few graphs. And these are the answers you should get. So don't get confused here. This is just the answers of all the coordinates you have to plot for the questions, okay? And the answers for blue, that means as long as you've got a straight line passing through those points. Yeah, you've got a straight line passing through here. And here, these two coordinates is going to be correct. I hope that's clear. Moving on. Right, straight lines in real life.
It's rumored that Machi-san has taken hand-eye coordination beyond every other human on Earth. He claims to be able to cut a speeding bullet in midair. So we've come to a firing range outside the hills of LA to see if it's true. This is the size of the pellet Machi-san would try to slice with his sword.
I honestly don't believe I could cut this if it was stationary on a chopping block with a chef knife. He's going to do it while it's flying through the air with a samurai sword.
Not only is the pellet tiny, over 4,000 times smaller than a baseball, but when it leaves the barrel of the BB gun, it's traveling over 200 miles per hour. A normal person would have no chance of seeing the pellet.
So samurai were elite fighters in Japan in the past. And they use their swords with straight lines. If you think of motion of swords traveling in a straight line, to be elite fighters and warriors. And this is an expert samurai, and he's going to use his sword skills, but his maths, to cut a small BB gun pellet in half. It's very amazing. Exceptional reaction time, vision and response. It is a superhuman ability.
So we're using a slow motion camera to slow the action down by 250 times. And helping me is Dr. Ramani Durvasula.
Okay, we're ready, Kay.
Kay is going to fire the pellet at Machi-san from a distance of 70 feet.
I heard it, but I didn't see
You can hear
it.
that, he got it.
The blade
He
went
got
by.
that BB.
All right,
pellet.
we're
That's
gonna play
amazing.
back. We're gonna play back.
Using the slow motion camera, I want to see if Machi-san has achieved the superhuman.
Look at that straight line graph. Perfect.
That was amazing.
Awesome.
But how does Dr. Ramani explain what she's just witnessed?
This is about processing at an entirely different sensory level because he's not visually processing. This is a different level of anticipatory processing, something so procedural, something so fluid for him.
A normal person would take 3/10 of a second just to register the sound of the gun being fired before they can even start to think about reacting. By the time they moved the sword into position, the pellet would have traveled past them.
I think, yep, this is the one. You can see the little nick in it. This tiny little thing, the nick he took out with his sword.
The power of maths, guys.
This is absolutely superhuman.
By linear, we mean that the function must create a straight line graph, and the power of x must be 1. And we'll learn more about this later. Linear equations are generally in the form of y equals mx plus c, and sometimes you'll see it as y equals mx plus b as well, but don't worry about that. It's the same thing, just using the different letter for c and b. That's more of a US type version. So y equals 12 minus 5x, that is a linear function because the power is 1. Now, even though you've got a power of 1 here, this is an x on its own, but you've got this which will affect the graph, so it is not a power, the power of x here is minus 2, so this is not a linear graph. Here, we've got the power of 1 here, but see that? We've got the cubed number here, and that would actually become a cubic graph. Okay, so that's not a linear graph, so that would not be a straight line graph. This is yes, because it's an x on its own. And here, well, there's no x squared, x cubed, or x to the power minus 2, and so that power of x is also 1 as well. That's something you need to know. Right. This is a challenge question. I would argue it's almost grade 5, because this is actually quite hard for people to do. You could do this mentally, or perhaps if you can rearrange equations, that's easier. So I'm going to start here, and I'm going to write, because it's in a form that you're not familiar with, so that's just going to confuse you. So let's make it into something we're familiar with. We want y on its own, so we're going to minus 3x on both sides. So now this becomes 2y equals 6 minus 3x. I would divide by 2, so that's everything's divided by 2 here, so that becomes y. Everything's divided by 2 on this line, so 6 divided by 2 equals 3. 3 divided by 2 is, so that becomes minus 1.5x. And like this, it might be a bit easier for you. So let's start with 0. You can see 3 minus, well, 1.5 times 0 is 0, so y is 3 here. So let's try x equals 1. So we're going to do x equals 1 here to show you how to do this. So y equals 3 minus 1.5 times 1. That's just going to be equal 3 to minus 1.5. So y equals 1.5. Now let's try when x equals 2. So you try this yourself as well if you want. 3 minus 2 times 1.5. So you should know that 2 times 1.5 is 3, so that becomes 3 minus 3. So y equals 0 there. And that's going to give you the correct answer. Can you see this pattern? What's happening in here? It's going by minus 1.5 each time. I'd argue this is a grade 5 question. And that's because of the pattern of the minus 1.5x here. So if it's going minus 1.5 that way, you can see it's going plus 1.5. So you'll know that this answer is 6. That's worth 2 marks. And you just plot the coordinates. To do this, so 0, 3, 1, 1.5, 2, 0, And normally 3 and there you go. Perfect. Do try that yourselves to see if you can do that. Right, 2 exam questions for you to try, and this is what I mean. They don't give you a table. If they do not give you a table, the amount of students I've seen this throw off is quite surprising. Just do one yourself. And it says do it for the values of x from -1 to 3. It's good to see this as an exam question, so you get used to the wording. And then you don't need to do a full table. Just say x is -1 here. 0, 1, 2, 3. And you've got your y. Now, let's start with the 0. I always start with the 0, but you can start with the 1 if you want, if you prefer. So, remember, 3 times 0 minus 2 is going to give you -2, because this bit is 0. Now 3 times 1 is 3, minus 2 is 1. 2 times 3 is 6, minus 2 is 4. And I know the pattern is going up +3, so I'm going to just put a 7 there, and that's -5. Just plot those coordinates. 1, 1, 2, 4, 3, 7. You could try and print out these sheets to try yourself, or just draw out the graph yourself if you want to give these questions a go. 0 minus 2. Now, if you plot a coordinate somewhere like up here, or get an answer that's just this, and you know it's a linear graph, you know you've gone wrong somewhere. And just try that question again. Point for there. And then those are the points, and just try and draw a straight line through there. And use a ruler, that'll get you full marks. Now this is why I showed you the more challenging example before, because this will throw off even the most able students, because it just appears in a different way. Well, there's 2 ways you would do this, or I would do this. Just make it y equal, so get y on its own, which is change the subject, so you just need to minus the x on both sides. Now that becomes y equals 5 minus x. Do your little table of values, and that's very easy for you to do right now. Now, or I could do, I know that x plus y equals 5, right? And it just depends on the question, what technique you use. Do the technique that works best for you. But I would just probably do this. So if x equals 0, how am I going to make this 5? Well, if x equals 0, essentially plus y equals 5, then I know y has to equal 5, right? So that's 1 down. Now if x equals 1 plus something equals 5, which is the y, well, you've got to be able to do that. That's 4. That's 1, 4. So if x is 2, 2 add what makes 5. And once you know how to do this, it's actually very easy, but it does throw people off. Plot those points. Draw the line, and that is perfect. This bit is obviously wrong, because it's a straight line graph, it should go there. That will lose you a mark, guys, so be careful. How else could you go wrong? Negative numbers, maybe. Make a mistake with negative numbers. Be careful with the scale. And just tick off what you can do here. Rag it. I think you've all done very well. And that is the end. Well done, guys.